Hi guys, welcome to our last section of chapter 2 where we are modeling with quadratic functions. Your learning target is I can solve a real life problem with a quadratic function. So we're just going to jump into our first example. The parabola below shows the path of your first golf shot, where x is the horizontal distance in yards and y is the corresponding height in yards. The path of your second shot is modeled by the function. Which shot traveled farther before hitting the ground, and which shot traveled higher? So let's first look at the picture, because just by looking at the picture of our first shot, we can see how far the ball traveled and how high it traveled. So what this graph has been used for, we put our shot, basically looking at it from the side, we can see that we have a set of axes here, a y-axis and an x-axis. And on the x-axis, we have our x-intercepts. So our x-intercepts represent when the ball is on the ground. So obviously we see the ball starts at the ground at 0, 0, and it ends on the ground at 100, 0. Those are our two x-intercepts. So we know that the ball traveled horizontally 100 yards. Then it also gives us this very important point here, our maximum point, which is our vertex. And we know that after it traveled 50 yards, it was at a maximum height of 25 yards. And it should make sense that our vertex is at the x value of 50, because 50 is halfway between 0 and 100, and your vertex is always on your axis of symmetry, which is halfway between your x-intercepts. Okay, now let's see if we can figure this stuff out from our function of our second shot. Our function of our second shot is in intercept form. So we should be able to just look at our function and know our x-intercepts. So first of all, this number out here, this negative 0.02, does not affect our x-intercepts. Only we need to look for is the x and the x minus 80. And we ask ourselves, what would make those two expressions equal 0? Well, the only thing I can put in for a plain x for it to be 0 would be 0. So my first x-intercept is 0, 0. And then to make x minus 80 equal 0, I would put in a positive 80. So my second x-intercept is 80, 0. I'm just going to draw a rough sketch of this to kind of help me compare it to the first shot. Here's 0, 0, and we'll say that is 80, 0. So right away, hey, we know how far the ball traveled. It traveled 80 yards, which is not as far as the first shot traveled. So we already know the answer to part A. Which shot traveled farther? It is the first shot. Okay, to figure out which shot traveled higher, we need to find the vertex of our second graph. So since we know our x-intercepts are at 0 and 80, we find our axis of symmetry, which is halfway between 0 and 80 would be 40. And remember, to find the y-coordinate of our vertex, we plug the x value from the axis of symmetry into our function. So I'm going to find f of 40. So I'm going to take negative 0.02 times 40 times 40 minus 80. Now you can plug this into your calculator, and in fact you're going to want to, but I can do 40 minus 80 in my head, and I get negative 40, and then 40 times the negative 40 is negative 1600. And then I'll take my calculator, which I did, a negative 0.02 times a negative 1600 gives me a positive 32, and that's 32 yards. So my vertex, the x-coordinate is at 40, the y-coordinate is 32, so it has a max height of 32 yards. So it looks like that one traveled higher than the first shot. So which shot traveled higher? The second. Okay, I'm going to do the next example and the last example for your work tonight in a different video. So go click the next link.